Howdy all. We are Group 13 and I, Rishabh, along with my friends Ding and Rungu, are going to present an elevator pitch on the topic of joint caching and routing in cache networks with arbitrary topology. We all wish to have a faster, reliable, and cost-effective network so that we don't face any issues when our favorite movie or sport is being telecasted. We all are aware of research done in caching and routing algorithms independently to reduce the network access time. We learned about the various algorithms to do this in our lectures. But we will present to you an exciting direction of combining both these technologies to achieve our goals. We will discuss an algorithm that optimizes caching and routing jointly, which improves the network performance by reducing data access time and network bandwidth usage. Okay, now coming to the cases of our research paper, we know that both caching and routing can be integral or fractional, hence giving us four cases in total. Integral caching, integral routing, ICIR, integral caching, fractional routing, ICFR, fractional caching, integral routing, and fractional caching, fractional routing, FCFR. We focused on joint caching and routing in a cache network with arbitrary topology, and our objective is to minimize the routing cost under link or cache capacity constraints. That's how we will design an algorithm in this paper. We also characterize the complexity of the problem in all the cases and develop polynomial time algorithms that achieve grunted approximations in important special cases. Optimizing towards the total routing cost will be NP hard for most cases. Now the question is, how can we approach this problem with a polynomial time approach? It remains a research challenge. To solve this, we break down this problem into three parts. First, we will consider two special cases with relaxation, which will be unlimited link capacities and binary cache capacities. Then we will consider the overall problem in a normal setting. First relaxation is when each link is light loaded. We just need to request from the nearest node. So the problem in this case can be reduced to route to nearest replica RNR problem with the goal of minimizing the cost and finding a good content placement within the network. We have a theoretical guarantee of this algorithm. It's a polynomial time complexity related to number of nodes, number of edges, and number of serving requests in the network. And the bound of objective will be achieved as 1 minus 1 by E. Now coming to the second relaxation, that is when each node store entire catalog or nothing. In this case, the routing problem can be reduced to a single source routing problem in an auxiliary graph with the goal of minimizing the cost of serving all the requests in the auxiliary graph. Again, the theoretical guarantee is that the time complexity of solving MSUFP is a polynomial time complex related to the number of edges and the number of nodes in the graph. With this, we can have an overview of our algorithm, and the algorithm can be divided into two main steps. First, we maximize the objective within cache capacity constraint to find a placement for the caching content. And second, we solve the routing problem for MMSFP or UFP on the graph. Now that our algorithm is ready, let's see the evaluation and the results of this algorithm. The results of our study have shown that our proposed algorithm outperforms state-of-art solutions in cost and congestion. And another benefit is that it converges quickly within 10 iterations. As we can see from the figure, in unlimited link capacities case, algorithm 1 outperforms state-of-art solutions, and advantage remains as the number of candidate paths for k shortest paths increases. And for the binary cache capacities case, algorithm 2 with larger k reduces congestion while achieving minimum routing cost achievable without congestion. So let's come to the conclusion. Our algorithms can be extended to large-scale networks and real-world applications, making it a practical solution for the network optimization. With this algorithm, you can reduce data access time and minimize network congestion and save on network bandwidth cost. In conclusion, I would like to say that A joint caching and routing algorithm is a valuable tool for anyone interested in optimizing their network. Its benefits are numerous, and it offers a practical and effective solution for improving the network performance. That's it from my side. Thank you.